Thousands of tons of superheated water pass through the plant's pipes every minute. If that water stops being cooled, the temperature of the equipment will begin to rise rapidly. The turbines will have to be shut down, electricity production will drop, and the plant itself could be pushed to the brink of an emergency shutdown. It would seem that solving such a problem would require enormous fans and powerful motors. But the engineers found a far more unconventional solution. They built a giant concrete tower the height of a 20-story building and made it pump millions of cubic meters of air without a single motor. The entire secret lay in one narrow section in the middle of the structure. After passing through it, the air inside the tower began to accelerate on its own, as if someone had switched on a giant invisible fan. What's most surprising is that if you removed that narrowing and made the walls straight, the cooling efficiency would drop drastically, even though the tower would look virtually the same from the outside. How did a simple curve in a concrete wall become one of the most brilliant engineering tricks of the 20th century? And why, without it, would many power plants look completely different? At the beginning of the 20th century, European cities were growing very rapidly. Power plants ran at full capacity, factories produced tons of goods, and to keep them running, a colossal amount of energy was required. In the Dutch city of Heerlen, coal mines and related industries operated day and night. To prevent heavy machinery from overheating due to constant rotation, engineers used ordinary water. The boiling water had to be cooled somewhere. So the builders erected the first cooling towers from the simplest and most accessible material, ordinary wood. At first glance, everything seemed to go according to plan, but the wood deteriorated quickly and rotted due to constant moisture and hot steam. These structures didn't last long, and factories had to stop frequently for repairs. An entirely new solution was needed. Durable and long-lasting, capable of handling enormous volumes of water. But then the builders immediately ran into a very human problem. When ordinary citizens learned about the massive new constructions being erected in the middle of working-class neighborhoods, very strange rumors began to spread. In those years, the global situation was extremely tense, and people lived in constant fear for their future. Many said openly that under the guise of peaceful industrial facilities, government agencies were secretly building closed testing bases. Others whispered to their neighbors that inside these towers, secret materials were being stored. Residents sincerely believed that these mysterious installations could somehow harm them, ruin all the grass in neighboring fields and pollute the air in the region. But the real reason was far simpler. The authorities desperately wanted to ensure stable industrial operation without frequent shutdowns. However, building massive, heavy towers in that location turned out to be physically difficult due to the nature of the soil. The fact was that all the ground beneath the city had been completely hollowed out by abandoned underground mines. This fragile soil was constantly subsiding. Any heavy construction would simply collapse at the slightest ground shift. So two Dutch specialists, Frederik van Iterson and Gerard Kuipers, devised a very clever plan. They abandoned wood entirely and decided to use monolithic reinforced concrete. They molded an iconic round shape with very thin walls for such a scale, only about 15 centimeters thick. The tower came out very light and strong, and no ground movement could threaten it anymore. But during the first tests, the engineers encountered a new technical difficulty. The natural airflow inside this structure was far too weak, and the hot water from the plant couldn't cool down to the required temperature. A solution was urgently needed. A plain straight pipe is the worst option for cooling a large factory. When the first designers tried using standard cylindrical structures, they immediately ran into an insurmountable obstacle. Hot, moist steam rose upward but cooled very quickly at the exit edge and turned into a heavy cloud. This dense cloud of cold air sank back down and acted like a true plug at the top of the structure. The hot currents below could barely push through this air barrier. Factory boilers would overheat within minutes, and engineers had no idea how to make the air circulate on its own, without enormous electric fans that consumed too much precious energy. Old rules called for building chimneys of gigantic height, but thin concrete on unstable soil simply would not support such a colossal weight. While specialists searched for a solution on paper, frightening urban legends began to emerge around the circular structures. People in the neighborhoods seriously believed that inside these towers, artificial tornadoes were being created to control the climate in the region. Newspapers wrote that the new constructions functioned like gigantic vacuum cleaners, capable of disrupting bird migration. Residents on the outskirts genuinely feared that the constant invisible whirlwind would damage their buildings during strong winds. There were even rumors that these structures were secretly used by the armed forces to test new acoustic equipment, since inside the hollow concrete walls, a loud and strange echo formed. Residents demanded that the experiments be stopped, not realizing that those sinister sounds were simply the result of ordinary laws of acoustics. The solution to this complex problem lay in laws of physics that all of us use every day. Remember how a simple garden hose works when you press your finger over the tip. The moment the space for the water to pass through decreases, the speed of the flow instantly increases several times over. The engineers applied this principle and changed the shape of the tower. They created a unique hyperboloid that narrowed smoothly in the middle. When hot air reached the narrow throat of this concrete hourglass, it accelerated sharply and turned into a powerful internal hurricane. This flow rushed outward with a whistle, broke through the cold air barrier, and carried the heat far up into the sky. In this way, people achieved maximum power without a single motor. But just as the engineers conquered the internal wind, an external force of nature struck the structure. Now let's find out why 3 enormous towers in England collapsed like a house of cards. On November 1, 1965, in the north of England, an event occurred that deeply shook engineers around the world. At the newly built Ferrybridge power station, 3 enormous concrete cooling towers, as tall as 30-story buildings, came crashing down one after another in just 1 hour. That day, a powerful autumn storm had swept over the region, but the wind gusts did not exceed predicted values by any means. The structures were brand new, built from strong reinforced concrete and considered absolutely reliable. The operators at the main control panel first heard a dull and terrifying boom, and then through the window they witnessed an unbelievable scene. The gigantic gray walls rapidly became covered in a network of deep cracks. The structure gave way and lost stability in an instant. It was a terrible blow to the country's energy system. The operation of the enormous industrial complex was completely halted. The sudden collapse of 3 of the most important installations in broad daylight triggered an avalanche of loud and highly alarming rumors throughout society. It was a time of intense international tension. Articles about a planned foreign intervention appeared immediately in British newspapers. In working-class neighborhoods, people whispered to one another that the project management had secretly embezzled the allocated funds and used the cheapest, lowest-quality cement in the walls. A special commission launched an urgent investigation, while panicking ordinary citizens demanded that the station be shut down. People refused to believe that solid monolithic concrete, 13 centimeters thick, could be so easily destroyed by ordinary wind, however strong, without any external interference. But the experts' conclusions turned out to be far more serious than any rumor, because the cause of the incident was the pure physics of airflow, which nobody had studied before. On their own, the towers were built to a high standard, but the engineers had made a fatal mistake in how they positioned them on the site. 8 giant towers had been built very close together in a single row. When the stormy wind struck the first structure, its round, aerodynamic wall acted like a directional nozzle. This concrete curve sharply redirected the flow and sent it at enormous speed through the narrow gaps between the neighboring structures. The wind pressure between the towers increased dramatically, creating a powerful suction effect. And the storm struck the more distant structures with redoubled force. The thin walls simply could not withstand the pressure and gave way. This event changed the rules of global architecture forever. But just as engineers protected the external walls against hurricanes, a new problem emerged inside the tower. A sharp drop in thermal plant efficiency and the threat of generator shutdown. That was exactly the technical failure engineers encountered in the mid-20th century. The instruments on the control panels showed a paradoxical situation. A powerful current of air rose inside the concrete tower at enormous speed, but the technical water at the bottom remained hot. Because of this, the steam inside the system could not condense back into liquid. Pressure in the condensers rose, and the automatic system was forced to reduce electricity output. Specialists peered under the concrete vault of the giant and saw a tropical downpour inside. Enormous streams of boiling water fell from a great height, forming a continuous and heavy wall. The large droplets fell too fast. They simply couldn't release their heat into the passing cold air, and they hit the lower basin still warm. This thunderous, unrelenting waterfall inside the open concrete structures quickly gave rise to a series of frightening rumors among local residents. People around the industrial zones noticed that thick white clouds constantly poured out of the towers. An alarming theory about a hidden threat immediately spread among the population. It was claimed with full seriousness that inside the enormous structures, factories were secretly mixing water with chemical elements. The press published alarming articles stating that this artificial precipitation contained corrosive acid that would completely destroy crops in neighboring fields and damage the paint on rooftops. Residents sincerely believed that government agencies were concealing an environmental problem from them. These rumors were pure fiction, but the real engineering problem demanded an immediate response. To save the plant from a power drop, scientists drew on a simple law of geometry. A large lump of sugar takes quite some time to dissolve in a cup of tea. But if it's first ground into fine sand, it disappears in the water in just a few seconds. The engineers realized the continuous, heavy waterfall had to be transformed into billions of microscopic droplets. They installed a special system inside the tower, a massive horizontal network made up of thousands of thin plates. This element was called a spray nozzle system. Now the boiling water no longer fell in a continuous stream. The water was driven under pressure to nozzles and struck the plastic and concrete partitions with force. Each large droplet instantly shattered into a fine water mist. The surface area of liquid in contact with air increased thousands of times over. The wind instantly carried away the excess heat, and an already cool jet fell to the ground. But the moment the engineers transformed the heavy rain into a fine mist, it created a new problem outside the factory. A dense white wall of fog, completely blocking traffic on highways. And a genuine winter snowstorm in the middle of a warm autumn. That was the alarming climatic anomaly that residents of cities near large thermal power plants encountered at the end of the 20th century. These localized weather changes occurred strictly within the boundaries of the industrial zones. For example, in the American state of Pennsylvania, near the enormous cooling towers of the Big Valley Power Plant, meteorologists recorded a unique phenomenon on more than one occasion. The sky over the region remained absolutely clear and cloudless, but directly from the gigantic concrete towers, powerful white clouds poured out and settled in the streets in the form of a thick, sticky dampness. On cold days, this moisture instantly transformed into a thick layer of artificial snow, which covered the roads and created dangerous conditions. Ordinary citizens didn't understand the reasons behind what was happening and blamed the management of the industrial giants for everything. The appearance of these strange precipitations sparked serious debates in the scientific community. Meteorologists put forward a sweeping hypothesis about unintentional climate change caused by the heat from power plants. Researchers claimed that the colossal volumes of hot steam rising from the towers were capable of acting as powerful heat islands. According to theoretical calculations, these energy flows should permanently alter the direction of local winds and form a constant rain cloud for many kilometers around. In scientific journals, there was discussion that humanity had acquired a tool for controlling precipitation. Supporters of this hypothesis believed that the thermal emissions from cooling towers could be used to combat drought in fields by directing artificial clouds in a desired direction. In reality, the terrifying dense smoke was absolutely pure water vapor. This process works in exactly the same way as in an ordinary domestic kitchen when the kettle boils intensely on the stove. The white cloud above the spout is simply evaporated pure water, not a dangerous smoke emission. The physics of the process was simple. A fast current of air carried the tiny droplets produced by the spray system out of the tower. Outside, the warm moisture mixed with cold exterior air and turned into local fog or snow. But losing tons of fresh water was very costly for the factory's economy. To prevent these losses, engineers installed a special device at the top of the tower, a droplet collector. It consists of hundreds of curved plates resembling open blinds. The dense vapor rises, strikes these curves, and the water droplets simply run back down along them into the common pool below. Pure air rises into the sky, and the precious moisture remains within the production cycle. But just as the specialists had fully mastered the water and the air inside the tower, they were struck by a powerful blow from the planet's tectonic forces that nobody had anticipated. May 12, 2008. In China's Sichuan province, a massive earthquake strikes. The ground literally disappears from under people's feet, and underground tremors, in just a few seconds, compromise the integrity of buildings, bridges, and large factories. The enormous industrial zone of the region is completely destroyed. Yet in the midst of the chaos of rubble and choking dust, rescue teams witness an incredible scene. The gigantic hollow cooling towers stand absolutely intact. Their thin walls show no serious cracks, even though neighboring brick buildings and heavy industrial workshops have collapsed all the way down to their foundations. This seemed impossible. After all, these hollow concrete structures, more than 100 meters tall, had walls only about 20 centimeters thick. A commission of engineers arrived immediately at the site to understand how these fragile giants had withstood the colossal impact of nature's force. For a long time, the classical theory of absolute rigidity had dominated the construction of large industrial facilities. Old-school engineers were convinced that to protect against powerful underground tremors, any tall construction should be as massive, heavy, and monolithic as possible. Designers embedded thousands of tons of steel into foundations and built thick walls, turning factories into hermetically sealed defensive bunkers. The opposing hypothesis of elastic deformation claimed that rigid fixation was harmful for tall structures. Supporters of this theory believed that a structure should not resist the impact but instead move plastically along with the oscillating ground. Debates between the two schools stretched on for decades, since for a long time these complex mathematical calculations couldn't be verified under real conditions in practice. The Sichuan disaster clearly proved the validity of the elastic method. The secret of the phenomenal resistance lay in the unique geometry of the hyperboloid and the construction of its base. The entire enormous mass of the concrete colossus does not rest on a continuous foundation but on a lattice of inclined columns. They are arranged in a circle, set at an angle, and form sturdy Latin letter X shapes. When the earth begins to shake violently, these supports function as a unique load-distributing structure. They don't allow the construction to snap, instead, they instantly redirect the destructive energy of the wave, making it travel upward along the curved walls. The structure deforms slightly but holds its shape, like a resilient shell. And so people made the laws of geometry protect engineering from the outside. The enormous gray tower, devoid of expensive electronics and complex internal motors, turned out to be the perfect union of pure physics and precise calculation. Its strange, futuristic form is not an architect's whim but the absolute pinnacle of engineering thought, one that made nature itself work in humanity's favor.